Let's begin, everybody. So today's exercise, we're doing 2D. Now I've broken 2D, so we'll chuck our laptops away, guys. Broken 2D, you'll notice there's 4 parts to it, 2D, 1, 2, 3, 4. And we've decided to do it in a little bit of a different order, and we're well justified in doing so because we're doing it based on skill. Now there will be 2 parts to our lesson today again. It'll start easily, and then we get into some more complex ones that involve the factorising first. But what we're doing here is we have a quadratic. Here it's factorised already for us, and we're going to graph it, okay? So to graph a quadratic, we need 3 things. 2 roots, roots are the x-intercepts, Lincoln, and 1 y-intercept. So the first thing we're going to do is find the y-intercept. The y-intercept occurs when the x value is 0. If you think about a Cartesian plane, it's when it crosses the y-axis, all x values there are 0. So when we put 0 into this equation, what we have is positive 2 multiplied by negative 3. Alright, we're putting the number 0 into this equation here, and so that's going to give us a y-intercept of minus 6. Alright, so y-intercepts occur when x is 0, and similarly, the x-intercepts, where it crosses the x-axis, that occurs when y is 0. So what we're going to do is put 0 where the y is. So what we'd have x plus 2 times x take 3 equals 0. Alright, y is 0. And we've been solving these kind of equations in 2a.1. We apply the null factor law. Either x plus 2 is 0 or x take 3 is 0. And that gives us the solutions negative 2 and positive 3. Okay, now what we're going to do is we're going to sketch a graph with these features. So we have an x-intercept of minus 2 and positive 3. So I go to my Cartesian plane, minus 2 is about there, positive 3 is about there, and we have a y-intercept of minus 6. So that's going to be down here. And we have to draw a quadratic that goes through these points. Now, the minimum point, alright, the minimum or the maximum point, what we call the vertex, all quadratics are either going to do this or do this. They're what we call a parabola. They follow that kind of shape. So we can see this one, it has to go like this because it's passing through this point, and this point. Alright, so it's going to look like that. Now the minimum point here, that's always going to occur halfway between the x-intercepts. Alright, the minimum point or the maximum point, what we call the vertex, always halfway between there. So between minus 2 and positive 3, that's going to be x is 0.5 on your axes or on your grid paper. Okay, so that's our first example. We've sketched the graph of a quadratic from this form just by finding the y-intercept and the x-intercept. It's a rough sketch, but it's indicative of the graph. Now, one way we could check our working is by going into our calculator and graphing that, and we would see the same features. When I come around, I'm going to make sure everyone knows how to do that. Okay, let's move on to the second example. We're going to repeat basically the same thing. Y-intercept when x is 0, so we'll put x is 0 into this equation. We've got this minus 2 out the front, that's just going to stay there, times positive 1 times negative 2. So we have minus 2 times 1 times minus 2, that gives us positive 4. Alright. X-intercepts occur when y is 0. So that means our function minus 2 times x plus 1 times 3x take 2 equals 0. We've set the function to 0. Now what we have here is we have 3 things multiplying together, right? Well, minus 2, that doesn't equal 0, so that's not part of the null factor law, but x plus 1 could be 0, or 3x take 2 is 0. I'm going to clear off this message about potato cakes. All right, we solve both of those. Here we get x is minus 1. Here we'll get 3x is 2. X is 2/3. 2 on 3, 0.6 recurring. All right, so just quickly, what do? We put x is 0 into the equation. That gave us the y-intercept. We set the equation equal to 0. That gives us the x-intercepts. And now we're ready to graph it. So we have an x-intercept of minus 1. So minus 1, I'm going to have a big scale here. I'm going to say that's minus 1, and that can be positive 1. So we're crossing there. The other root that we have is 2/3. So if you think, if this is positive 1, 2/3, well, it's going to be 1/3. It's going to be about there. That's x is 2/3. That's the second root. And the y-intercept is positive 4. So we'll put that up there. That's going to be our y-intercept. And so we have a parabola that goes through these, has to go like this. All right, and the maximum point occurring there somewhere. All right, so again, we can get that, we can graph this in our calculator and observe that shape. G solve those x-intercepts, G solve the y-intercept. Really good. Okay, that's A and B. Let's look at question 2. And in question 2, we're doing the opposite. In question 2, we're given a graph and we're told find the equation of this quadratic. And the graph that we're given looks like this. So we have a Cartesian plane, we have a y-intercept of positive 3, x-intercepts of minus 1 and minus 3. Okay, so that's what our graph looks like. Now, the default form that this graph is going to take is like this. Y equals A times x take P times x take Q. What we've done here is express the quadratic in terms of its roots. Remember, if its roots are P and Q, we can express it like this. X take P and x take Q. Now, our x-intercepts are minus 3. So we're going to put minus 3 where the P is. And positive 1 where the Q is. So we have y is A times x take negative 3 and x take positive 1. So I'm putting 1 where the Q is and negative 3 where the P is. That's because they're the roots, they're the x-intercepts. We'll just simplify that a little bit and we'll have x plus 3, x take 1. Now we always have this A value out the front that we're going to solve. We're going to solve it using the y-intercept. Most of the time the A value will be 1, but we need to check. So we've got the y-intercept occurs when x is 0. So what we know is when x is 0, the y value is 3. When x is 0, the y value is 3. We're going to plug that into this equation. I'm going to put 3 where the y is and 0 where the x is. Alright, so we know when x is 0, y is 3. I've put 3 where the y is, 0 where the x is. And what we have is we have 3 equals negative 3 times by a. So therefore the value of a has to be negative 1. We divide both sides by negative 3. We have a equals negative 1. Which means the equation of this quadratic is y equals negative 1, x plus 3, x take 1. Now we can check our answer by sketching that on our calculator and observing that it has the same features of the graph we did here. So there's two approaches here. The first approach is when you're given an equation and you go from an equation to a graph using a manual process. The second approach is where you're given a graph and you go from the graph to the equation. We need to be competent with both. Now just up here in terms of notation, I've written -1 times this. However, The 1 you don't need. Often it will just be written as negative of this function. That means minus 1 log of it. Really good. So that's enough to get started on 2D lesson 1, because what's going to happen here is we're going to look at the two forms a quadratic can be expressed in. So in the previous questions we were just doing, we saw quadratics like this. They were expressed in what we call linear factors. We have one linear factor multiplied by another linear factor. That's linear factor form. Here, this is the general form. We were looking at that the other day when we were doing quadratic formula, right? Our value of A, B, and C. Now, in this question, we're given a quadratic in general form, and we are going to graph it from general form. I've got a process written at the top of the page. We're going to follow that exactly. Step 1 says identify the y-intercept. This is really easy in general form because the y-intercept occurs when x is 0. Alright, so the y-intercept for our first question here is -8. Step 1 complete. We identified the y-intercept. Alright, step 2 says factorize the quadratic. So we're looking at this and we're going to move from general form to factorized form. How do we do that? We're looking for two numbers that multiply together to give us -8. And when we add them together, we get +2. So that's going to be +4 and -2, right? So we can express this quadratic like this. If you expand this, you'll get the exact same as we had up here. If you FOIL it, you'll get that exactly. We've changed, it's the same function expressed in a different form. It's got a different outfit in it. All right. So we've factorized a quadratic. Step 3, identify the roots. Okay, roots occur when the function equals 0. We make it equal to 0, we apply the null factor law. And so we've got our roots, x is -4 or x is +2. Okay, so this is the new part that we're introducing you to. It says identify the axis of symmetry and the coordinates of the vertex. So the vertex means that maximum or minimum point. Now there are two ways to do this, okay? The vertex occurs exactly halfway between these. So we can just go -4, so the first root, plus the second root, divided by 2. Alright, -4 plus 2, that's going to be +2, divided by 2 is 1. The x value of the vertex is 1. So we have the x value of the vertex, then we need the y value. And the way we find the y value is we can put the number 1 into either this function or this function. It doesn't matter what we put it in, it's going to end up the same. They're the same function. I'm going to put it in here to the first one. So we have the y value is going to be 1 plus 2 take away 8. When I put the number 1 in here, 1 plus 2 take 8. So that's going to be 3 take 8 -5. So we have an x value and a y value for the vertex. X is 1, y is -5. Now that's one way we can get the vertex, but here there's another formula listed as well. Smile. And the formula is listed at the top of the page. X is -b divided by 2a. -b divided by 2a. Can everyone see that one there? Alright, this is the x coordinate of the vertex. So this is another way that we can arrive at this x value. It's either halfway between the roots, the average of the roots, or we can do -b, so -2, b is 2, divided by 2 times a is 1. Why is this going to be different? -2, this gives us -1. Why is that different? Here, sorry, -4 plus 2, that's -2. -2 divided by 2 is -1. So they should These should be the same. Two methods of finding the vertex. All right, the first one, the average of the roots. The second one, the formula minus b on 2a. Doesn't matter which one you use, you get the x value. The vertex occurs when x is minus 1. Now this is going to change our y value a little bit. Sorry, no one pick this up. So when we put x is minus 1 in here, we'll have minus 1 squared. So that's going to be positive 1. But then we have 2 times minus 1. That's going to be minus 2. All right, so that gives us a vertex of minus 9. Okay, all of those features we can G-solve from the graph. Now we're ready to graph. We have everything that we need. We have the x-intercepts, the y-intercepts, and the vertex. So x-intercept at minus 4 and positive 2. We have the y-intercept is negative 8. Okay, so we're familiar with that. But now we're adding in this vertex, which is x is negative 1, y is minus 9. That's the vertex. Now when we say vertex, that means the turning point, the local minimum. And so our function then looks like this. Okay, it goes through minus 4 and 2. That's the lowest point at x is minus 1, y is minus 9, and the y-intercept of minus 8. So we're just combining all of those skills together. All right, we'll do this second one as well. Any questions about the first one? Okay, good. So, step 1, find the y-intercept. Okay, y-intercept is going to be positive 8. Step 2, factorize. So if we're going to factorize this function, we're going to set it equal to 0. We're going to factorize it. There's a couple of things we can do here. Let's set it equal to 0. And if we're trying to find when the roots occur, one thing we could do is recognize that minus 2 is common to all of these numbers. In fact, we could express the quadratic like this. And that's going to be take 4. All right, so I want to point out a link between these two, because this is much easier for us to manage, right? I'm looking at these going, 2 is a factor of all of these terms, and so if I pull minus 2 out the front, if I now expand this, I would get exactly what we had here, but that quadratic is much easier for us to factorize than this one. If there's an easy way for us to do it, we should always look for it. Okay, so we're going to factorize this quadratic. We're looking for two numbers that multiply together to give us minus 4, add together to give us positive 3. That minus 2 is going to hang out. We're going to have x take x plus 4 and x take 1. All right, 4 times minus 1 is minus 4. 4 plus minus 1 is positive 3. So we've factorized it. Let's apply the null factor law. Alright, so we have x is negative 4 or x is positive 1. Let's find the vertex, the coordinates of the vertex. And we can use either process, b divided by 2a, or the average of the roots. That's minus 3 on 2. Okay, and then we need the corresponding y value. When x is minus 3 on 2, we're going to say what's the y value, and we're going to put it into this equation. Okay, so we can type either that into RunMap, or if you've graphed the function, you can G-solve those points. And so I think that's what I'll do, just because it'll probably be a little bit faster, and I'll be able to see all of the features. So in my graph mode, I'm graphing the original function. and the vertex is occurring at minus 1.5, minus 3 on 2, and the y value is 12.5. Okay, if we process all of that, we get positive 12.5. So we're ready to sketch the quadratic now. All right, we've got all of the information that we need. We can use our calculator to help us, but we've shown all of the working out there, haven't we? So our roots are -4 and +1. We have a y-intercept of +8, and the vertex is at 1.5 and 12.5. And so then, if we're drawing a parabola that goes through those points, this is the shape it has to take. Okay, one more thing I want to point out about both of these examples is at the top you've got written, if A is positive, you have a happy face, and if A is negative, you have a sad face. Look at both of these quadratics that we've done. The first one we did, the A value is +1, and what do we notice about its shape? It's a happy face. In the second one, our A value is -2, and what do we notice about its shape? It's sad face, it's opening downwards. So the A value out the front dictates its shape. It helps us to understand, is it going to open upwards or open downwards? All right, that's enough for us to move on to 2D.3. So we're going to do some